I'm pleased to have Julia Barnes, maker of Sea of Life and Bright Green Lies. Julia is a filmmaker. Julia, what else would you like for our audience to know about you?
That's a good amount. Yeah, filmmaker, very passionate about ocean issues, and lately I've been involved in a lot of activism around the issue of deep sea mining, which is probably something we'll talk quite a bit about today.
Great. So you have a presentation for us. Take it away.
Awesome. I'll share my screen. All right. So yeah, today I'm going to be chatting with you a bit about the greenwashing of industries in the ocean. So kind of the way that companies are pushing to open up new frontiers of exploitation on the sea, to increase the exploitation that's currently going on in the sea. But a lot of this is going on under the guise of protection or sustainability. But I want to start this presentation by giving people a sense of what is already happening in the ocean, the kind of baseline of where we're at today, because the ocean is already in trouble in so many different ways. Industrial fishing has wreaked havoc on the ocean. Humans have been kind of exerting pressure and an influence on the ocean probably for the last 10, 12,000 years, as long as we've had civilizations, but really things started to get bad a couple of 100 years ago and have really accelerated exponentially. So right now we're at a point where 90% of the large fish have been wiped out from the ocean. So that's fish like sailfish, tuna, mahi-mahi, sharks, any kind of big fish you can think of. On average, their populations have been reduced to 10% of what they should be. Industrial fishing operations, the technology has become so, what's the word for it? So much more specific. Like nowadays, a lot of companies use sonar, and they can pinpoint exactly where a big group of fish is, so they can go in with a net and scoop them out, and fish don't really stand a chance anymore. They can't hide from people who want to take them out. And really what we're seeing is, I'm not even sure it can be called fishing anymore. It's more like the mass theft of life from the sea, because you just get these huge nets that go in, whether it's bottom trawling, regular trawling, purse seines, or things like long lining with miles of baited hooks. And they're the kind of industrial scale factory fishing operations that are taking place today are removing huge chunks of life from the ocean and removing fish at a rate so much faster than they can reproduce. But these industries are also incredibly wasteful. It's estimated that 54 billion pounds of fish is brought out of the ocean every year, caught and thrown back and discarded as waste because they weren't the target species. So when a fishery is going after a particular type of fish, oftentimes they're also catching other fish that are not as commercially viable, or they're catching, sea turtles, sharks, seabirds even, or marine mammals. So we have these fishing methods going on that are, a lot of fisheries are kind of on the brink of collapse or collapsing. And we're seeing this removal of nutrients from the ocean without giving anything back. And I think that's something really important to understand, that there's something kind of fundamentally unnatural about this process, about these large-scale commercial fisheries, because when you think about it, like if a fish is in the ocean and eating, one fish eats another fish, all of the nutrients still remain in the ocean, and they're either in the body of that fish or in the excrement of that fish. But when humans remove life from the ocean, we're moving those nutrients essentially permanently out of the ocean and bringing them onto land. where they no longer benefit the ocean. And so we've seen this huge decline in biomass and the amount of life in the ocean, and obviously really negative effects from that, because in nature there is no surplus, there is no extra. Everything, every individual, every species exists for a reason and has a role to play in the ocean, in the environment. Another thing that's happening that's really important to understand is the collapse of coral reefs. And corals are really important because they support 25 to 30% of all species in the ocean at some stage in their life cycle. So they're really key to the health of the ocean. But they cover less than 1% of the seafloor. So they're also one of the most biodiverse communities in the ocean. And they, when I started filmmaking and getting involved in ocean issues over 10 years ago, the stat was that 50% of the world's coral reefs had been wiped out already. Since then, the situation has gotten much worse for corals, and I don't have an updated number, but we can say well over 50% of the world's coral reefs are gone. And, the threats facing corals kind of range from like direct habitat destruction, and in some cases there's like fishing going on reefs that involves setting off bombs and things that are completely crazy that destroy coral reefs. But even something as seemingly trivial as like people wearing sunscreen when they go to the beach, the chemicals get into the seawater and they're really damaging to coral reefs. If a piece of plastic is touching a coral's skin, that coral becomes much more susceptible to diseases than it would be if the plastic wasn't touching it. So plastic does something really bad to corals' immune systems, it turns out. You have also like the impact of fishing on coral reefs. When fish populations are reduced, corals tend to be less healthy, which makes sense because fish play a lot of key roles in maintaining the health of a coral ecosystem. But the big kind of overarching threats to coral reefs are ocean acidification and ocean warming, and the resulting coral bleaching is something that's even affecting corals much faster and much more immediately. So, when I was filming my first documentary, Sea of Life, there was a mass bleaching event on the Great Barrier Reef, which was a really big deal, kind of the first thing we'd seen like that. But since then, there have been a couple more mass bleachings on the Great Barrier Reef. All of the corals in Florida bleached recently. So these are becoming really frequent and severe. And then obviously the acidification of the ocean.
What's the bleaching caused by?
It's caused by ocean warming. So the ocean absorbs 90% of the excess heat from climate change. So whatever warming we're experiencing in our atmosphere and on land, it's happening 10 times faster in the ocean. And so when the water temperature becomes too hot for too long, corals have a very, they have a particular temperature range that they can tolerate. And unlike other organisms like fish, we're seeing a change in the distribution of fish, and we're seeing a change in the migration patterns of fish. They tend to move towards colder water because they need a certain temperature to survive. But corals are stuck where they are. They can't pick up and move somewhere if the temperature becomes too hot. So it stresses them out. They release these symbiotic algae inside their tissue, which are what give them their color and also what give them a lot of the nutrients that they need to survive. And that's why they turn white, because without the algae, they don't have their color. You can see right through their skeletons. And that's why it's called bleaching, because they just appear white, like someone's poured bleach on them.
Right.
But without those algae, they can't really survive for very long. So sometimes corals can recover after a bleaching event, sometimes not, and it depends on the interval of time between bleaching events. Like some of the scientists who I spoke to about corals said, like, if bleaching, and obviously depends on the severity of the bleaching event, but if it occurs at an interval of like 10 years apart from each other, then corals can usually recover from that. But if it's happening more frequently, any more frequently than 10 years, which we're already seeing it is happening more frequently than that, then they can't really recover from that. So another big thing to be concerned about in terms of what's happening to the ocean is plankton populations. The ocean is really important, and plankton are maybe the most important organisms on the planet. They are the base of the oceanic food web. They feed almost everyone in the ocean, either directly or indirectly. They're so important to the life in the ocean. But plankton also produce most of the oxygen in the air that we breathe. 2 out of every 3 breaths we take come from plant life in the ocean. And so the ocean also big supporter of all life on land, all of the animals on land. We rely on the ocean in order to be able to exist and breathe. And plankton populations have been decreased by about 40% already, and we're losing them at a rate of about 1% per year. And that's largely caused by some of the same things that are affecting corals, ocean warming and ocean acidification combined, because the synergistic effects of those 2 issues are also much more powerful than those 2 things individually. Like they've done studies in labs where they subject, say, coral to just the ocean, like just the water becoming warmer, or just the water becoming more acidic, and they can kind of, maybe handle each of those individually, but you combine the 2 stressors at the same time, and they can't handle that. And so it's similar what's happening to plankton. But another issue affecting plankton is the fact that we have seen complete decimation of the populations of whales. There are so many fewer whales in the ocean than there should be, than there were before whaling. The whaling industry wiped out 3 million whales, and the population of whales around the world is currently about 85% less than what it should be. So we have this huge deficiency of whales in our ocean. And whales would normally be providing some nutrients and some fertilization, essentially, because when whales poop, their poo is this perfect, floaty, frothy package of nutrients that support the growth of plankton. And the whales deliver this in the right quantities, in the right locations, the right distribution, kind of perfect for plankton to thrive.
If you would, let me jump in and just summarize some of what you're saying. So the oceans are getting warmer because the air is getting warmer, and the oceans absorb most of that heat. The oceans are getting more acidic because of additional carbon dioxide in the air. So you're saying that corals can handle either the warming or the acidification, but they can't handle both. So it'd be good if we could either lower the temperatures or lower the carbon dioxide in the atmosphere, or somehow make the oceans less acidic. And
it's not quite as simple as that. It's not like
sure.
I can blanket statement say they can handle one or the other.
Yeah,
All
right.
I'm saying is that in lab experiments it's been shown that when you combine the 2, the effects are much greater than the sum of their parts. But obviously, even just one or even just the other, if it gets bad to a certain extent, ocean acidification on its own, once it reaches a certain level of acidity, coral reefs literally start dissolving. So it's predicted that if ocean acidification continues by 2070, coral reefs, not only will they not be able to form, the ones that exist will be dissolving because of the acidity of the water. So no, it's not like just making one of those problems disappear would mean that the corals would be able to survive the other one. All I'm saying is that when you combine the 2, it's not just like 1 plus 1. It's more like 1 times the other. Like the magnitude of the impact is much more severe.
Sure. Okay. And then the other thing is the absence of whale poo, which would otherwise be a great fertilizer and cycling of nutrients, et cetera. And if whale populations are down by 85%, then that's 85% less of that nutrient cycling that they would otherwise provide.
Mm-hmm. Yeah, exactly. Yeah, so these are all big things that are impacting the ocean, and so I just wanted to put this talk in the context of, and here's the next one that I'm about to get to is we're seeing also, I mentioned the kind of removal and theft of nutrients from the ocean in terms of industrial fisheries taking life out of the ocean. It's not going to come back. Also, yeah, the lack of nutrients with whale poop and those whales being missing. But we also have this problem of an influx of some, what you could call nutrients in the form of runoff from agriculture. And so I suppose it's not like we're not sending nutrients into the ocean. We're sending way too much, the wrong quantities in the wrong places. And the fertilizer runoff from agriculture is having a huge negative impact on the ocean as well, because if there's too much nutrients in places in the ocean, you get these blooms of algae, sometimes blooms of toxic algae. And when, there's so much, there's too much, there's not enough other species that can eat that plant matter. And it ends up decomposing in the water, and the decomposition process eats up a lot of the oxygen in the water, and then the seawater becomes deoxygenated. So this is a process called eutrophication, and basically it creates these areas called dead zones, where if a fish swims into these areas, the fish can't breathe. There's not enough oxygen in the water, so they suffocate. We have
So let me stop. I've been wondering about this. So what is it that causes the dead zones? You're saying that the dead zone is caused by a deficiency in oxygen in the water. And what causes that deficiency in oxygen?
Yeah, so it's runoff from fertilizer or pesticides from agriculture. So yeah, it creates these big blooms of algae or plankton or toxic algal blooms, and then when those decompose, it uses up the oxygen.
So the extra nitrogen in the fertilizer somehow causes an algal bloom. Now I'm confused because I think of algae as a plant, and I think of plants as taking in carbon dioxide and producing oxygen, but apparently they don't have that effect.
No, they do have that effect, but what happens is when they decompose, the bacteria that decompose those plants, they take the oxygen out of the water.
Okay, now I get it.
CO2. So yeah, it's the whole sum of the process, because the plants don't just stay there. They, if nobody eats them, they've got to decompose.
Interesting.
Yeah.
While we're talking about fertilizers, so in the public mind, we think of, oh, fertilizers are necessary for food, and humans need food, but we could grow our crops without fertilizer, certainly with a greatly reduced amount of fertilizer. We could also grow our crops with less tillage, which tends to increase erosion. We could also grow less of the type of crop that is essentially useless, such as corn ethanol. So there's a lot of changes that could be made. It's not the agricultural runoff is by no means necessary for humans to survive or thrive. In fact, quite the opposite.
Yeah, that's a really good point. Yeah. So because of the way that agriculture is being done right now, there are currently 400 of these deoxygenated areas in the ocean on average at any given time. Which is obviously quite problematic, and they tend to be expanding, and we tend to be finding more and more of them in the ocean as these really intensive agricultural processes are continuing. So yeah, that's just to give people a sense and a context for this presentation of where the ocean is at right now. The oceans are really in a state of collapse in a lot of ways under all of the assaults of industrial civilization and the kind of pressures that these industries have been exerting on the ocean. Everything that's been moved, everything that's been put in. I haven't even mentioned plastic pollution, but that's obviously another big issue that's affecting the ocean. There's just so much going on that we're really at a point where if we want to secure healthy ocean, which I think should be everyone's priority if we understand how important the ocean is for the functioning of our planet, for making this planet habitable for us and all species. We should be prioritizing having a healthy ocean, having an ocean that supports life, and bringing back life to the ocean. Because the ocean that we see today is not at all indicative of what the ocean should look like. The ocean should be teeming with life. It should be full of fish. It should be full of whales. It should have so much more going on. And what we see today is a really depleted and really degraded ocean. And I think we could see a big change and a big improvement in terms of the health of the ocean. There are examples of places where people, stop fishing, stop certain industries, and you see a rebounding of life in the sea in those areas. It's not like it's always a happy story. There are some places where, there's been a moratorium on a certain fishery because the fish populations were collapsing, and those fish populations still haven't come back. So it's not like you can always rely on the resilience of the ocean, but there definitely are enough examples of the ocean being very resilient that I think if we, pulled back and stopped a lot of the things that are actively degrading the ocean, I think we could see a huge improvement and a huge return of life to the sea.
Well, let me ask you about there's this thing called 30 by 30, like protecting 30% of
Mhm.
the world by 2030.
Yeah.
And some of that applies to the oceans. What are the prospects for that kind of program? Has it done some good, and are there still some concerns? Is there some greenwashing or some half measures involved?
Yeah, I'm glad you brought that up. That's actually something that I'm going to get to in a couple
Okay.
of slides. Yeah, I'm going to mention something to do with that. I don't know what the prospects are of 30 by 30 actually happening. Obviously, I think I'm in favor of any kind of large-scale protection of the ocean. To try and confine it to a certain percentage. It's like Sylvia Earle sometimes says, like, the ocean is the heart of our planet. How much of your heart do you want to protect? Like, are you
Right.
okay with sacrificing 50% of it? I don't know.
Right.
Yeah, we'll talk a bit about that because obviously there's some issues in terms of what does it actually even mean for an area to be protected. Because oftentimes when we hear the word protection, we think it means a certain thing, but what it actually means on paper might be something completely different. So yeah, that is a really interesting issue to delve into. But anyways, the point that I wanted to make right now is just like, I think, yeah, we could go in a good direction if we wanted to. We could see a big improvement in the ocean, and I think that's what we should be doing. But at the same time, what we're seeing happening in the real world is that doesn't seem to be the goal. Like, industries are really trying to double down on exploitation, to push new frontiers of exploitation. But I kind of just wanted to lay this out as being the baseline of where the ocean is at right now. And we're kind of at a crossroads, right? Like, we could go in a good direction, but there's a lot of forces that are trying to continue with the things that have been historically very harmful to the ocean, and then to add new harmful industries on top of that. So
Right.
this term that has become a buzzword in the world of ocean conservation, ocean industries, is the blue economy. And yeah, I started hearing this word quite a lot. I started hearing it a lot around the issue of deep sea mining, which is interesting. And of course, naturally started wondering what it actually means. If you look up the blue economy, you'll find that a whole bunch of different organizations and different people have tried to define it, and definitions really vary, but they pretty much all tend to involve some language around sustainability or better stewardship or conservation. And this was the result that Google pulled up from Oxford Languages for the blue economy. And this definition describes it as an economic system or sector that seeks to conserve marine and freshwater environments while using them in a sustainable way to develop economic growth and produce resources such as energy and food. So this definition, but kind of most of the definitions that I've seen of the blue economy, it's really interesting because they all come at it from the lens of like the dominant culture and the kind of values and unquestioned assumptions that are inherent to that culture. So kind of within this definition is baked in like the idea that the ocean is a resource for humans to exploit, that economic growth is desirable and a good thing, and that the resources of the ocean can be developed in a sustainable way, which all seems pretty contradictory to me, and seriously problematic. But I wanted to highlight this term just to, I think it's really interesting to kind of get a look at how industries operating in the ocean can really be, we can spin the language around which we talk about them. And it's very easy to kind of greenwash the negative effects of industries. And I ended up finding this little infographic from Energy Industry Review that talks about some of the sectors within a blue economy. So you have things like shipping, fisheries, offshore oil and gas, renewable energy, mineral resources, so that would include deep sea mining, coastal and marine tourism, aquaculture, which if you're wondering if fish farming is a good or bad thing for the ocean, I would highly recommend reading the book Not on My Watch by Alexandra Morton. You need only look at the fish farms off the coast of BC to see what a complete disaster they are. And biotechnology, which is bioprospecting, marine genetic resources, the kind of commodification and privatization of the DNA of our non-human kin in the ocean. All of these sectors and industries, I would argue the ocean would be better off without. And a lot of them, most of them, maybe all of them, I don't think can be done in a way that is sustainable. I think unsustainability is inherent to what they are. Although I will say the word sustainable, I think, has kind of become one of the most meaningless words in the English language. Like people tend to just slap it on top of whatever destructive industrial process they wanted to do to begin with, and it's supposed to somehow deflect criticism. But of course, the real world effects of sustainable fisheries are still that they're wiping life out of the ocean. It's still that theft of life from the ocean. Sustainable energy sources are still assaults on the natural world in their own right. And you could go through all of the kinds of things that are trying to use this label. We're just seeing this huge prevalence of greenwashing, which makes sense because, this is kind of a natural response of industries when people become concerned about an issue. it's like more and more people are starting to realize that some really bad things are happening in the ocean, starting to realize that, maybe industrial fisheries are not having a good impact on the ocean, starting to realize that deep sea mining is maybe not a good idea. And, much easier than actually changing what's happening at sea is to change the language with which we talk about these things, and to try to, persuade people that something that is really actually harmful is somehow beneficial. And this is kind of a trend that I've noticed. A while ago, the High Seas Treaty was released. And this is tying back into that idea of 30 by 30, because the bunch of governments came to an agreement, a consensus on this treaty to govern different industries taking place on the high seas, environmental impact assessment stuff with the high seas, and also a framework under which it might be possible to create marine protected areas on the high seas. So we had this treaty. It was, I think, like a 54-page document. I read through the entire thing because I was seeing everywhere conservation groups, individuals, news media commenting on this thing and making all sorts of claims about it. They were saying that because we had this high seas treaty, then it would mean that 30% of the ocean would be protected by 2030. That was one of the things that a lot of people said. They were saying that this would regulate and cause there to be stricter regulations on deep sea mining. That was another thing. A lot of just celebratory language saying this is a really historic agreement and that this means there'll be more protection for the ocean. And when you actually read the document, it's dry and tedious, but anyone can access it and read it. So it's really inexcusable that there was so much false information circulating about what this thing actually is. Because when you read it, nothing in there says that 30% of the ocean will be protected by 2030. There's no commitment to any percentage or number or amount of protection of the ocean. All it is laying out a framework under which it would be possible to go about the process of creating a marine protected area on the high seas. And I would argue that it actually makes it pretty difficult to create a marine protected area, because there are so many different countries that are involved in signing onto this agreement. Anyone who's been following the climate conferences, the COP conferences over the years, probably understands how difficult it is for large numbers of countries to come to consensus on big issues. And to create a marine protected area would under this treaty require consensus or 2/3 majority vote amongst the member countries. So who knows in terms of the viability of that, in terms of the likelihood that marine protected areas would be very easy to create under this agreement. But another issue is, what does protection actually mean? Because, when you hear the word protection, you tend to think, okay, so there won't be any industries happening, right? Like it'll be cordoned off and left on its own, left to do its own thing as, as a natural area. That's typically what people think of when they think of a protected area. But under this high seas treaty, a protected area could be an area that is being sustainably used or sustainably managed. In other words, there could be industrial processes taking place in the so-called protected areas. So protection does not necessarily at all mean what people would think it would mean. Might not really mean protected at all. And, once again, this whole theme of like the erosion of language, definitions are really important. Like, what are we actually talking about here? What do we mean when we say an area is protected? And if an area is protected, but also there's a commercial fishery taking place in that area, I might argue that that's not really being protected. but under some definition, it would count as that. So that was one of the issues with the High Seas Treaty. Also, obviously, people were claiming that this would have a positive impact on the issue of deep sea mining, but it explicitly exempted deep sea mining from environmental impact assessment measures. Deep sea mining is governed by an entirely different governing body. So there was just so much false information being spread about this High Seas Treaty, and a lot of hype around it, and this kind of public image and conception of this idea that we had a huge progress in terms of protection of the ocean. But the reality is, I don't know, it doesn't seem to make that big of a difference at all. Maybe it's not even a positive thing. But
it reminds me of the quote that Derek Jensen often quotes from Henry Adams: "The press is the hired agent of a moneyed system and exists for no other and is set up for no other purpose than to tell lies where their interests are involved." So there are industrial interests that benefit from the lies or the half-truths, whatever you want to call them, that are being purveyed by these organizations.
Mm-hmm. Yeah, and I think it does a great disservice to ocean conservation to have people going around thinking that the issue is being taken care of, right? Like, governments have got this. Oh, don't worry, 30% is going to be protected by 2030. Meanwhile, that's not the case, but people have been kind of placated into believing that everything is okay. So then they don't have to take action. They don't have to pressure their governments to do something different. They don't have to, think about these issues too much. So yeah, it kind of just creates this false sense of security for the ocean.
Exactly.
And it's really masking this new era of exploitation that corporations are planning. Yeah. When we think we've got progress, actually everything is moving in the wrong direction.
Yeah.
And we saw a similar thing with, I found out recently, the World Trade Organization had come to some kind of agreement about stopping harmful subsidies to industrial fisheries, which sounds really great. Like I would love to have less subsidies, or no subsidies preferably, going to industrial fisheries. These subsidies are literally fueling overfishing, destructive fishing, that might not otherwise even be economically viable. So this was another thing that was celebrated and hyped up. And I know people who have been working on trying to achieve a similar goal, to try to reduce the harmful subsidies to fisheries, for decades, like Dr. Daniel Pauly, who is a fisheries biologist, does really cool, amazing work. And I was reading his written comments on this agreement, the World Trade Organization agreement, and he basically said that it's meaningless and it's so full of loopholes. Like, it doesn't really do anything good for the issue. And it's just like, yeah, this is a theme that keeps coming up again and again. It is, we have all these kind of flashy moves going on, or the way that it's spun by the media, to make
generally speaking, treaties and agreements that are written under the World Trade Organization, which includes NAFTA for one thing, but those treaties and agreements give companies the right to sue any locality, any state, province, or country that has any regulation that might pose a threat to their profits. And the corporation wins almost every time. And these lawsuits have eliminated environmental protections, labor protections, any type of state-sponsored enterprise that cuts into the profits of corporations. So that's the general thrust of the World Trade Organization, is to eliminate the right of governments to protect their own citizens in favor of corporate profits.
Yeah. I mean, obviously, the World Trade Organization is the World Trade Organization. And yeah, like when I saw that the treaty was, or the agreement was done by the World Trade Organization, I mean, immediately that starts raising red flags. This is not exactly known
The
for
fox guarding the hen house.
yeah, exactly. So yeah, backing up a little bit in this story, I got involved in ocean issues because over a decade ago, I started working on a documentary about some of these big things happening in the ocean. That documentary took 3 years. I interviewed a whole bunch of scientists. I learned a lot about what's happening in the ocean. And I was also, you know, traveling to these big climate marches, attending these big environmental demonstrations that were going on at the time, which tended to be really focused on calling for more subsidies, for more mass proliferation of technologies like solar panels and wind turbines. Green growth was being talked about a lot. There was a phrase like jobs, justice, climate change. And I, you know, coming from the understanding that I had of the issues facing the planet and where they stemmed from, I felt like there was this huge disconnect, and I felt like something was really wrong in the mainstream environmental movement and the way that it approached these issues with like a very simplistic idea around solutions, and something that seemed to not be addressing the root causes of the problem at all. It was basically the narrative in the mainstream movement was like, we can continue with the way of life that we're accustomed to, with the systems that we have set up. We don't need to question those things. We can even keep having a growth economy. We just have to switch the fuel source and power it a little bit differently, and then everything will be okay. And you know, that just didn't match with my understanding of the issues, because like a solar powered bottom trawler is going to destroy the ocean just as much as one that's powered by fossil fuels. But I, you know, so something just didn't feel right about this. But I didn't really know the details. I didn't really know how harmful solar panels and wind turbines and all of these like so-called green technologies are to the planet. At the time, I just thought they're definitely insufficient to solve the problems because they're not addressing the root of the problem. But I ended up, funny enough, at one of those climate marches, I met a guy who said that the work of Derek Jensen had inspired him to become an activist. And so I went home and I looked up Derek and I watched his Endgame talk and started reading his book, Endgame, which is really excellent. And I went and interviewed him because I thought his work was really important and I wanted to include him in the film that I was making. And I ended up learning that he was working on a book along with Max and Lier about the fact that all of these things that have been sold to us as being green and clean and sustainable and solutions to our environmental problems, about the harm and the extractivism and all of that that is inherent to the process of making these things, and how, yeah, solar panels and wind turbines and hydro and electric cars are not saviors for the planet. They're not going to save the day. And in fact, they're really making things worse. So I ended up making another documentary all about that because I thought that was really important. At the time, the book was you know, being written. It hadn't come out yet. And so I made the kind of film version of the book, and they both came out at about the same time. So those are my two feature documentaries. One about the destruction taking place in the ocean, and another about the lies and greenwashing surrounding so-called clean energy. And then when I learned about this issue of deep sea mining, which was new to me, but obviously it had been going on for many decades, kind of quietly in the background. But it really was not a popular or well-known or well-understood ocean issue. But when I learned about that, it really felt like a convergence of these kind of two themes that had encapsulated many, many years of my life making these documentaries, because what corporations are planning on doing for this particular sector of the so-called blue economy is targeting an area of the ocean in international waters, 4,000 meters deep, roughly, and extracting metals from that part of the ocean, which, just on the surface does not sound like a very good idea. But the more you learn about it, the more I learned about it, the more I started to become really horrified and really concerned. But what's interesting is that the justification that was being given at the time when I was learning about these issues, the justification for mining the deep sea was, oh, we've got to do this in order to produce batteries for energy storage from solar panels and wind turbines, batteries for electric cars. It was all about this kind of green techno savior kind of mentality. And the companies that are interested in mining the deep sea, they had very much framed the issue as, the deep sea is a desert. Don't worry, nothing lives down there. We're not going to hurt anything, which couldn't be further from the truth. The deep sea is full of incredible organisms, full of life, full of biodiversity. And, it's just a whole other world down there. Like everything, it's very cold. There's a lot of pressure. Everything kind of takes place on a much longer time scale. Metabolisms are naturally slower generally because it's cold. And so it turns out you can have deep sea corals who are 4,000 years old. You can have deep sea sponges who live to be 11,000 years old. And the very things that these companies want to extract from the deep sea, the very things that they want to mine, are often the only hard substrate in an otherwise very muddy bottom of the seafloor. And so these are the things that the corals need to attach to, that the sponges grow on and anchor themselves on, and that a whole bunch of organisms, it turns out, depend on these things that companies want to extract. They're called polymetallic nodules or manganese nodules. That's often how you'll hear them referred to. There was a recent study that estimated that 50% of all life in this region of the deep sea depends on polymetallic nodules for their very existence. So this is really key habitat. They want to remove it. Once they remove it, it is permanently gone. It's not coming back. These things take millions of years to form. And they're really important. So the reason companies are interested in them is because they contain trace amounts of metals like nickel, copper, cobalt, and manganese. And these can be used in batteries. They can also be used for military applications. And one of the interesting things that has happened kind of lately is that companies that are going after that are pursuing deep sea mining have kind of changed their tune from being like, we're here to save the environment and we're doing this to produce electric vehicles, which of course I would argue is not saving the environment in any way. But that was their kind of narrative. But now they've really switched and they're like pursuing military buyers a lot more aggressively. So, and part of that might just be the fact that a lot of car manufacturers and technology manufacturers have signed up to say, we're not going to accept metals that come from the deep sea because the ethical concerns around doing this, I guess, are so strong. Like they're recognizing, and I don't mean to say that these car manufacturers are very ethical in any way, right? Like they're still going to be sourcing the lithium for their electric vehicle batteries and all of these different components for their batteries from somewhere else, from somewhere on land. And I don't think anywhere that it comes from is an ethical way to source it. We see terrible damage from lithium mines. We see terrible damage from cobalt mines, from whatever form of mining you can think of, anywhere that it's taking place on the planet. I don't think mining should happen. But a lot of these companies have recognized that there's enough public concern around this issue that they're worried that their customers aren't going to buy their products if they contain metals that come from the deep sea. So this is kind of an interesting development. But obviously, companies that want to extract minerals from the deep sea, they're doing it for profit, and the illusion that the narrative that they care about the planet is like just kind of ridiculous. They're going to sell these wherever they can sell them, and they're doing it to make a whole bunch of money. That's their goal. So this is kind of a diagram to show what deep sea mining might look like, and basically it would involve a mining machine moving along the sea floor, extracting everything in its path, sending those materials up through a pipe to a ship on the surface. As the mining machine is moving at depth, it's going to be creating huge plumes of sediment, and it's also going to be sucking up a lot of that sediment, and that stuff is going to end up at the surface. So on the ship at the surface, there is expected to be some initial processing that goes on, separating the components that a company wants from the stuff that it doesn't want, including whatever else got pulled up, which also includes sediment. So then there would be a discharge of wastewater into the water column at some depth that we don't know what it would be necessarily. Also conceivable that it would be dumped at the surface. Of course, nobody really knows. Commercial deep sea mining has not begun yet. Ideally, it won't begin ever, because this is not something that should happen in our ocean. But yeah, that's kind of to give you a sense of what it might look like. And then likely outcomes of seabed mining: direct destruction of habitat, obviously, because the habitat is the very thing that they're wanting to mine. But also any organism that is in the way of a mining machine that can't move and get out of the way is going to be sucked up along with the polymetallic nodules. Also, organisms that can move aren't necessarily going to be safe, because they can't necessarily outrun the plume of sediment that is being created by these machines, and that sediment can smother organisms and suffocate them. And corals in the surrounding area, or sponges, they're filter feeders, and they get completely clogged up by plumes of sediment. And there have been studies on species of deep sea coral exposing them to different amounts of sediment. And one of these studies, I was hearing from scientists about the early results before it was published, and they said not a single coral survived the experiment aside from the control group. So no level of sediment was safe for the deep sea corals. So yeah, there's light pollution, noise pollution, increased acidification of the deep sea, because what is being stirred up is carbon, essentially. Species extinction is considered a likely outcome. Obviously quite concerning. Yeah, sediment plumes that can pollute the entire water column, toxins and heavy metals that accumulate in the food web. There's also been found that radioactive waste would be produced by this mining, and increased carbon emissions, increased turbidity, which affects plankton potentially, and then altering the geochemical processes. So really what we're talking about here is the deep sea is the largest active carbon sink on the planet, and mining it would permanently damage its ability to sequester carbon. So yeah, the idea that this is like being done in favor of the climate is just blown out of the water when you think of the fact that like what's being sacrificed is the largest carbon sink we have, is something that's really important to the climate. Yeah, so there's a lot of concerns around this issue, around this industry. But yeah, one of the biggest.
What have you seen? I'm sorry to interrupt. What have you seen in terms of the coverage? I've seen a little bit of coverage where they try to kind of both sides it. Some people think this, and then some people think that.
Yeah, that's usually what you see, and that's kind of a thing that the media has been criticized for that quite a bit, particularly on the issue of climate change, because they would always do this thing where they tried to find someone who two people who had opposite positions on the issue, even though that was not representative of the actual proportions of people who were on both sides of the issue, right? Like it could be like 90% of people were on the side of thinking one thing, and they found the like one person who had an oppositional view, but they just pit one person against one person, so people watching the show think it's like 50-50 split. Yeah, typically the coverage that I've seen of deep sea mining tends to listen to what industry has to say, repeat back industry talking points, interview people who are in the business of mining the deep sea, but then take their comments around environmental impacts almost as if they were talking to someone who was like an objective observer or an objective like scientist studying this or something. Like, yeah, it's kind of weird. And then they would, yeah, sometimes they would have like a few voices or one person who thought, yeah, deep sea mining is kind of risky and we shouldn't do this. But yeah, it's really the coverage tends to be pitted in favor of industry, and a big emphasis on, oh, but could this be good for the environment? Oh, could we be saving the planet by mining the deep sea because we're just going to somehow help with climate change? Yeah, the coverage has been problematic in a lot of ways. I mean, obviously there's been some better coverage in more like independent outlets that have talked about, you know, all of the potential harms that this could cause, but oftentimes, yeah, it's kind of just glossed over. Sometimes it's just like, oh yeah, you know, some people, some activists, some environmentalists are like concerned that this might have a negative impact on the ocean, but oh, we're going to produce millions of electric cars and that's going to be really good for the planet. So yeah, yeah, I mean, like you were saying earlier, the press, what does it really exist for? But yeah, so a big concern for a lot of people who are watching this issue is the plumes that would be created, because the sediment from the deep sea can stay suspended in the water column for months at a time. And it's something that, you know, the areas that they want to mine are like key migratory areas for fish. And fish are breathing all the time, just like we are. And when they swim through one of these plumes, the sediment particles get into their gills and clog them up and damage their ability to breathe, and it can suffocate fish. So this is like kind of the big concern. Obviously, all aspects of deep sea mining.
Talk a little bit about the amount of like waste that is dumped into the ocean on a daily basis by one of these vessels.
Yeah.
Like many thousands of garbage truck loads,
Mm-hmm.
dump truck loads, the equivalent of it. I don't know if you had that information at your fingertips.
It's not in front of me, but I can go and find it if you want.
That's okay. That's okay. Let's just say a lot. I mean, as I recall from our previous interview, it was about thousands of dump truck loads a day, something like that.
Yeah, it is. It's just an incredible amount, and whatever that number was, that's just for one mining
operation. Yeah.
But potentially there would be loads of these all happening kind of adjacent to each other, spread out over this area of the ocean that is as wide as the United States. So yeah, yeah, it was just like a monumentally large number.
Right.
The amount of waste. Yes. Sorry, I don't have that.
That's fine.
This is a video that I wanted to share just to give you the sense of how easy it is to stir up and like kind of how the sediment from the deep sea behaves. So this is a rover from like a scientific expedition, just moving a little bit on the seabed. Wow. And, you know, as you can see, the plume just like, and this is like obviously a much smaller, much lighter vehicle than the deep sea mining machines that they're planning on sending down. Are house-sized machines. They're like massive and they're very heavy. So yeah, that's just to kind of give you a sense of how this material behaves, because also like a lot of the modeling that has been done around deep sea mining has used sand as a modeling substrate, and sand sinks back down much more quickly. But the sediment from the deep sea, like I said earlier, it can be suspended in the water column for months at a time. It's very, very light. It's very fine particulate matter, and it doesn't just readily sink back down.
Can we see the video again?
Sure. So
So
yeah,
this
this
is a small scientific vessel, much smaller and lighter than anything that would be involved in the industrial operations. And just a little bit of disturbance churns up this much of a cloud that affects fish's ability to breathe, for one thing.
Yeah. So that footage comes from a NOAA expedition.
Okay.
And this video I wanted to share, it's like a little excerpt from a larger video that was done on this issue, and I encourage people to look it up and watch it. The video is called Blue Peril, and it this little clip shows the results of some independent modeling that was done by some scientists to look at the spread of sediment, how far it would travel, how far these plumes would travel from one area called the Tonga contract area in this larger region that companies are looking at mining. So this is like one mining operation going on, and then I'll show you how much it spreads.
Wow.
Yeah. So it ends up reaching Kiribati and Hawaii.
Oh my gosh.
Yeah.
One mining operation, multiply that by however many they have planned.
Yeah. Pretty scary. I mean, think
so
about
that looks like, hundreds of miles at least, if not 1,000 or
it's
more.
a huge portion of the ocean. Yeah.
Mm-hmm.
Very concerning.
Right.
So the circle on this map, the big larger oval in the middle of the screen there, is the Clarion-Clipperton Zone. So that's the area that is currently being targeted for deep sea mining. The Peru Basin, which is the smaller circle there, is where some test mining occurred like around 30 years ago. And that test provided a kind of interesting experiment. It's called DISCOL. And they like returned to the area, I think 26 years after they had done the simulated mining, and they found that it had not recovered. Not really surprising.
Right.
This is a map that shows some different areas that include polymetallic nodules or manganese nodules. And so all of the ones that are shaded in green. So it's not just the Clarion-Clipperton Zone. Potentially there's all of these other areas, other big swaths of the ocean that could come under threat for this particular type of mining. But then there's also lots of other types of deep sea mining that are being explored. So on this map, it also shows cobalt crusts and polymetallic sulfides or hydrothermal vents. So those are the areas in yellow or orange. So just to give a sense of like potentially huge, many different swaths of the ocean could come under threat if this industry is allowed to go ahead. So there's already been a couple of companies that have produced prototype mining machines and sent them down into the ocean and done test mining. These are typically, I think, 1/4 scale mining machines compared to the size of the machines that they intend on using if they do commercial deep sea mining. One of the companies ended up pulling up, I believe it was 3,000 tons or pounds, 3,000 tons, I think, of polymetallic nodules during one of these tests. And when I look at that image, I mean, think about the amount of surface area on the ocean floor that would have covered, all of that being really important habitat probably having a lot of organisms living on these polymetallic nodules, never mind the really complex and amazing communities of microbes that live in the polymetallic nodules.
So
And
we're looking at a product of the mining, and the target mineral that they're going for is only a small portion of the polymetallic nodules.
yeah,
And the polymetallic nodules are only a small portion of the ocean floor, the area that gets disturbed.
mhm.
So tiny, tiny fraction, take this pile of product here and multiply it by however many thousand or tens of thousands or hundreds of thousands, and you get a better idea of the area that's being disturbed.
Yeah, exactly. And then when you think that this little pile, I mean, it's not little, obviously, it's quite huge, but this pile in the hull of this ship is only a really teensy tiny fraction of the area of the amount of metal or polymetallic nodules that they plan on extracting from the deep sea. Like, this is one test. This is not commercial scale mining. So yeah, I mean, it's just like really horrifying if you really think and imagine and visualize what all of this actually represents, what that represents in terms of habitat destruction, in terms of loss of life in the sea. And that's not even including, obviously, what's not pictured here is the plumes and the sediment and the noise pollution and the light pollution and all of these other things that are affecting life in the deep sea.
Another issue here is that you've mentioned this, but this is not just for so-called renewable energy.
Mhm.
This is for industrial applications, military applications. Currently, China has a virtual monopoly on the mining of rare earth minerals. The
Mhm.
US has to have China's rare earth minerals to do its military industrial complex. And at some point, the US is going to want to get rare earth minerals elsewhere other than from China. And, so even if like a lot of let's say Volkswagen and Tesla and GM decide to not buy minerals sourced from the deep sea, the US military defense contractors they have virtually a blank check. They can't pass an audit. $1 trillion a year, conservatively speaking. There's no reason to think that if there isn't an absolute moratorium on this kind of operation, that it isn't going to, it's going to be exploited, even if your urban liberal driving a Tesla is, not supposedly not using minerals sourced from the deep sea.
Mhm. Yeah, good point. Um, So yeah, I think that's about all I was going to say about deep sea mining. Just at the point we're at right now, there's I think 25 countries that have supported a position in favor of a moratorium, precautionary pause, or a ban on deep sea mining. There are 167 countries plus the EU that are members of the governing body, the International Seabed Authority. So yeah, a long way to go on this issue in terms of trying to push for moratorium at the kind of governance scale, international level. Um, and it's an issue that is relatively unknown still. I mean, a lot of people have never heard of deep sea mining, don't know what it is, don't know that it's being planned, and obviously people can't, fight for something that they don't even know is happening. Um, so other sectors of the blue economy, I kind of wanted to go through some of them, and you know, energy extraction is a big part of that, and I think that represents a big part of the new types of industries for the ocean. Um, to me, I don't see a big difference between looking at something like uh, offshore oil drilling and looking at something like offshore wind. I know a lot of people who are involved in fighting against offshore wind energy installation projects off of the East Coast and the West Coast of North America. And, one of the problems that people who are fighting against these things often come up against is other people's perception of the issue. They'll say things like, oh, but we need these, and this is helping to fight climate change, and this is a good thing, and we shouldn't be, fighting against it. And it's interesting because, hearing from some of the people who are working on these issues, they've read through like the reports and the environmental impact assessment statements of the companies that are wanting to install these things. And their own reports oftentimes admit that these will have zero or like negligible impact on carbon emissions. And this is something that I think is really important for people to understand, and that I try to like get this point across as often as I can, is the way that we think around issues with energy is often so out of touch with reality, because we have this narrative that there is a baseline demand for energy, right, that society requires, and that if you can meet that demand with energy from alternative sources, then you'll be reducing an equivalent amount of energy from things like fossil fuel sources. And that way of thinking of the issue is really flawed and out of touch with the reality, because the reality is something completely different. We have essentially an infinite demand for energy in the current economy, the way that things are set up. And any new energy that is produced is essentially sucked into this vacuum of infinite demand. So it's like we see the rise in data centers and all these new kind of things like Bitcoin mining, it turns out, is going to be one of the main consumers of energy from some of these offshore wind energy projects. It's like there's constantly new things popping up that are guzzling energy, and people talk about it.
AI.
Yeah, exactly. And people talk about, we hear the buzzword all the time of an energy transition. But what's actually happening in the real world on a global scale, if you look at a graph of all of the energy sources, it's an energy addition, right? Like new sources of energy are stacking on top of other sources of energy. They're not displacing them, they're not decreasing. It's just, whatever any kilowatts that can be added to the system will find a use for, and it'll take that energy and it'll keep using the old sources of energy. And so, with all of the increase that we've seen in solar panels, wind turbines, hydro, whatever, on a global scale, which is the only scale that matters when you're talking about a global issue like climate change, there has not been a decrease in fossil fuel consumption. Fossil fuel consumption has actually increased at the same time as these so-called alternative energy sources have been increasing. Just this idea that one displaces the other, that an equivalent amount of kilowatt hours from wind will equal an equivalent amount less being used from fossil fuels. This is not how it works in the real world. And that's really important to understand, and really important in terms of our conception of these things as being green or being alternatives even.
Right.
Obviously, these aren't alternatives to fossil fuels, because when you look at a massive structure like an offshore wind turbine made out of metals, made out of things that were extracted, shipped all over the world, manufactured, smelted with high heat, when you think, the plastics that go into them, the petrochemicals, the oil, lubricants, when you think about everything about this relies on fossil fuels, is produced by fossil fuels. These might last 25 years, optimistically, and then they would have to be replaced all over again. And so the idea that green technology is good for the planet or is anyway like independent of the fossil fuel economy is just really flawed and not true. And like, if we want to reduce emissions, we actually have to look at contracting the economy. The answer is not, let's build up a whole bunch of new energy sources. But I wanted to bring up this issue and this industry of offshore wind, partly because, yeah, I know a lot of people who are fighting against it and having a really hard time because they're coming up against all of this kind of, very much ingrained narrative that people have and the preconceived notions that we have around these things. And really offshore wind is like more of a subsidy grab than anything. It's like there's a lot of money being funneled into these things because, maybe well-intentioned, like there's a recognition that we have a problem with climate change. But subsidies are being funneled into these things because somehow producing wind turbines or solar panels equals addressing climate change, which it doesn't.
Right.
This is the story that people have told themselves. So yeah, we're in this really messed up situation where now suddenly there are these plans because the money's coming available, and there are these plans to just put thousands and thousands of these things off of the coasts. And I bring this up because this is a big problem for life in the sea. Particularly a big issue on the East Coast is whales, and they have a really important habitat area for this critically endangered species of whale, the North Atlantic right whale. There's less than 400 individuals of that species left. And the installation of offshore wind, just like a lot of other things in the sea, it causes, worse than a lot of other things in the sea, it causes, noise pollution. Whales, I don't think it's hard for humans to conceptualize the impact of noise pollution, I think, because we're a species, we primarily rely on our eyes, I would say, but also to us, noise pollution is like you hear the rumble of cars passing, or you hear noises on a city street or something, or construction, which is kind of disruptive and annoying, but not like a life-threatening issue. But with whales, they rely on their sense of hearing. They rely on this to communicate with each other. They rely on sound in order to navigate, to feed, to find food, to like everything. And the noises that are created in the ocean. So with the installation of wind turbines, for example, they do something called pile driving, which creates a very loud sound. But also anytime they're doing something like this, they have to map the seafloor first, and they go through with like sonic, like pulses of noise in order to map out what the seafloor looks like. And yeah, all of this is really disruptive to whales. It can damage their hearing. It can deafen them because the sound is so loud. And it can also just scare them away from the area. It can separate a mother whale from her baby. And if they can't find each other, usually both of them don't survive, because the baby obviously can't survive without its mother, but the mother spends all her energy searching the ocean to try and find her baby, and she won't eat, she won't sleep, she won't do anything. So yeah, anyways, this is really harmful, and I want people, when they look at offshore wind turbines, not to think that, oh, we're solving the climate crisis, but to think this is another assault on the ocean. This is something the ocean doesn't need, the ocean doesn't want, and it's just creating a lot of problems for the life that lives in the ocean. Never mind, also there's like a lot of cables that are going on underwater that connect all of these things to each other and to the land, where the energy obviously eventually wants to be used. And whales can get entangled in those cables. It can also disrupt a lot of species of sea life, because there's like electromagnetic fields, electromagnetic frequencies. Obviously, electricity is flowing through these cables, and so many species in the sea are really sensitive to electromagnetics. Like sharks are one example, but lots of other species. Anyways, I'm probably going on like way too long about this particular thing, but yeah, I thought that was worth pointing out, just because, yeah, this is another one of these like blue economy sectors that hasn't really gotten going yet on a big scale, but the plans of what they intend to do over like a relatively short period of time is pretty staggering, and is like just like huge swaths of the ocean once again that would be covered in these things, and not good for the ocean. So now I want to get into talking about whales and talking about the subject that kind of initially catalyzed this whole discussion to begin with, because you sent me a note asking about the issue of iron fertilization in the ocean. And yeah, like that people have come up with these ideas of putting iron in the ocean. And I guess this all ties back to this kind of blue economy, greenwashing of the ocean thing, because another sector that I don't think I even mentioned earlier is like ocean-based carbon credits and like selling carbon offsets that have to do with the sea. So we see this in terms of there's some schemes that have been dreamed up for like farming algae, like macro algae in the ocean, and then sometimes sinking it, or sometimes using it as a fuel source, or sometimes using it as food, but in many cases selling carbon offsets related to that. So anyways, to get back to this iron fertilization, kind of in a similar vein, people have dreamed up this idea of dumping iron into the ocean, because in some places in the ocean, iron is kind of a rate limiting nutrient for the production of plankton. And the idea being, you add in the iron and you see more growth in plankton. So in terms of the viability of this idea, there are kind of quite a few problems with it. One is just that there have been some studies looking at impacts of adding iron to the ocean and whether or not that would have an effect on carbon sequestration. And there's not very much evidence that it actually increases carbon sequestration. There have been like a few studies that have found kind of a marginal increase in carbon being sequestered, but there's also been a lot of studies that have found none or kind of negligible impact on carbon sequestration. So, you know, obviously an issue with like putting iron in and assuming everything goes right with it, selling carbon offsets from that. It's like, is there really being that much carbon being sequestered as what offsets they're selling as a result? And then carbon offsets are inherently problematic in the sense that they're really just a way of enabling and legitimizing more emissions, and kind of taking
One
credit.
thing that they claim to be doing is like kind of somehow the iron oxide jump starts the food chain and results in more salmon. I think they point to a study that says, look, salmon were revived in this area where we used iron oxide.
Mm-hmm. Yeah, which could be possible, but also I think it was just done like once, 1 year, and that's not really enough of a sample to get a sense of what would be the long-term effects. Is this something that's repeatable, or was that a fluke, or were there other factors that contributed to it? I don't know. And maybe it does increase, right? And maybe it does benefit those fish. There was also concerns around this, in that putting the nutrients in one area and promoting this proliferation in plankton populations in one area would deprive areas downstream of other nutrients, because plankton don't just consume iron, they consume other things out of the seawater. So like, yeah, things are a bit more complex. But even assuming like you could do this, and another concern with this was that if you get the concentrations wrong, even by a little bit, you could cause eutrophication, you could cause toxic algae blooms, you could promote the proliferation of harmful algae, and you could cause more of those dead zones that we talked about earlier. And I don't know that humans are wise enough to be able to get that right.
Exactly.
But assuming that it could be done and that it could have a positive impact on the ocean, it's a kind of weird thing to make the ocean dependent on this unnatural source of nutrients, right? Because this depends on there being ships to bring the iron out to the ocean, fuel for those ships, an entire industrial economy that gets the iron to those people who want to get the iron out into the ocean. And it depends on this all being profitable. So I don't know, let's say that you get this going, right? And this whole ecosystem blooms around this artificial input of iron to the ocean that humans are bringing. And then, the economy takes a turn, or carbon offsets aren't that valuable anymore. And the company is just like, well, we're not going to do this. We don't see the point in continuing. Well, then that ecosystem is going to collapse, right? Like it just seems like a really unstable, a really I don't know, kind of messed up way of doing things. And so what I wanted to bring into this conversation is the fact that traditionally the ocean was dependent on whales for that kind of fertilization of the ocean. And like I mentioned earlier in the presentation, whales poop, they fertilize the sea, they get it right every time they do it. They're really not going to cause toxic algae blooms. They're not going to over fertilize the ocean. And it makes sense for the ocean to be dependent on whales, because as long as there's healthy whale populations, the whales are going to consistently be doing this. They're not going to, stop if there's an economic downturn or if the company is no longer profitable or whatever. These are whales living in the ocean, living out their lives. And as a result of the fact that they're there, the ocean benefits from the so-called fertilizer that they produce with their poop. So it's a really good, really intelligent system that, if you build it around having whales in the ocean. And so, I think one of the reasons that the whole idea of iron fertilization could sound good and be a popular idea is because, just like the kind of solar panels and wind turbines thing, it's a quick fix. It's like a Band-Aid solution kind of thing. And it sounds relatively easy, like you just go out, throw some iron in the ocean. And it doesn't require all of the steps and all of the hard work that would be involved in something like bringing whales back to the ocean. Oh, and also, if you're going out and dumping iron in the ocean, you can profit off of that and you can turn that into a business model. Not necessarily something you can do with whales, right? Whales naturally living and swimming in the ocean. So, yeah, I mean, when you think about the fact that 85% of the population of whales that we should have in the ocean are not there right now, and whales really haven't recovered, obviously, since whaling. There's a huge potential, like bringing back whales to the historic numbers that they existed in. I think is the thing that we should be working towards. Like that would be a much better alternative than the iron fertilization thing. But that involves really challenging business as usual and really stopping a lot of industries that are currently posing threats to whales. Because right now, whales are facing the threats of ship strikes from, really interesting. Because of the amount, like people don't think of this. I think usually you think of the high seas with open ocean and you just think of an ocean that is like relatively pristine, but it's like an industrial highway and there are 50,000 container ships crisscrossing the ocean at any given time. They're going at a really high speed, pretty much the max speed that a whale can swim for, and the whales can't swim at that speed indefinitely, but the ships can, so they end up striking the whales. But the thing that was really interesting for me, in Canada, we had really big forest fires last summer, and I got into this habit of like looking up the air quality every time before I would go outside to see if it was safe to do so. And if you zoom out on an air quality map that shows you like the different colors to represent the different levels of air pollution, the worst air pollution like in the world is above the ocean, the open ocean, international waters. And you look at that and you're like, why? Why is that? You would think that the ocean would have some of the cleanest, most pristine air ever. You would think that the worst pollution would be around like industrial factories on land and coal-fired power plants or something like that. But it's above the ocean because these huge tankers and these container ships are burning bunker fuel, which is one of the worst air polluters ever. So that was kind of fascinating for me and horrifying, of course, because there is this already, like the ocean has been so industrialized, and there's all of these container ships going. So stopping that, stopping the global shipping and the trade of goods on ships, which is, oftentimes the most ridiculous things, like, I don't know, I've seen things like, pineapples that were grown, I don't know where they grow pineapples, but let's just pretend, like fruit that was grown in California, and then it was like shipped across the ocean to a factory in China to be packaged in a little plastic container, and then shipped across the ocean again back to the United States, where it was then sold to the consumer. It's just like, it's so nuts what goes on with shipping. Like, to relocalize economies would be a fantastic thing, to relocalize all food production, to relocalize all, production of anything.
Let me make an observation, something that came to mind when you talk about 50,000 ships at any given time. Business as usual only is going to make that grow. The economy grows by like 2 or 3% per year, and technology increases the speed and the size of these ships. And so business as usual is only going to be an increase. You can assume that over the course of time, if something grows at 3% per year, then by the rule of 72, it's going to it's going to double every 25 years or so. So we can only expect that 50,000 number to double in 25 years. And so all these faux solutions like iron oxide or mining for electric cars, they're false solutions because there's so much that they're a band-aid on an open wound. They don't prevent the growth of this of everything.
Yeah, exactly. Yeah, that's a really good point. And other threats to whales that you would have to address if you were gonna try to bring back populations of whales would be like entanglement in fishing gear is another really big issue for whales. So you would probably have to have bans on certain types of fishing gear. What else? Plastic pollution, which honestly, I mean, like, we know an easy thing would be to shut down the production of all unnecessary plastic products, but that's not going to take out what's already in the ocean. And it's just really incredible. Like, whales who are filter feeders, who are, say, feeding on krill, like a blue whale on average ingests 95 pounds of plastic per day. When it's feeding, like microplastic that's in the water, along with the things that the whale is trying to eat. And obviously it has no way of differentiating between those and what it swallows. And that, fills up their stomachs. A lot of whales end up washing up on shore and they have stomachs full of plastic, and they can't actually, like, they starve because they can't fill their stomachs with actual food that they need. in order to live. So yeah, there's I think those are the main ones. Oh yeah, and then obviously the other one being the noise pollution, which is a really big issue for whales as well. And that's not just installation of offshore wind or offshore oil platforms, but also things like military operations. A lot of times use sonic blasting and mapping of the seafloor. And there are projects right now that involve like trying to map out the entire ocean floor, and they use like pulses of noise to do that, and like they bounce back and then give them a picture of what the ocean floor looks like. This is really damaging, not just to whales, but to even it can like shred the bodies of plankton in the water column. The force of those sonic waves. So yeah, so there's like a lot of things that need to change if you're going to protect whales and bring back that function, the role that they play in the ocean. And obviously, dumping iron in the ocean, you don't have to worry about all of those things. So yeah, that's kind of the situation that we're in right now. But we need to be questioning things, challenging things, changing fundamental things about the way that society functions. And yeah, that's the path that we need to go down, not this kind of quick fix thing where we think we're solving a problem, but really we're just pushing it off. And I think that's it. That's it for my presentation. So yeah, if you want to chat more, stop sharing the screen there, about any of the stuff, you can do that.
Okay, great. Julia, this has been a wonderful conversation. It's just extremely important to talk about these issues and to try to stimulate awareness about what's really going on as opposed to what's being reported. These issues are not being reported with any consistency, any regularity, any emphasis in the mainstream media. How can our listeners and viewers follow you online, and how can they find your movies Sea of Life and Bright Green Lies?
Yeah, thanks so much for having me. It was great to have this conversation. And people can find the movies at the websites brightgreenlies.com and seaoflifemovie.com. And from either of those, you can figure out where to watch the films, and you can also find the book Bright Green Lies on brightgreenlies.com, which is really fantastic, and I highly recommend people reading that as well. Yeah, and people can follow, I think they can find all the social media accounts from those websites also.
Let's also give a plug for the book Bright Green Lies. So Julia wrote, produced, directed the movie Bright Green Lies based on the book Bright Green Lies. I've been a climate reporter for 5 years, and I can tell you that Bright Green Lies, in my view, is like it's the Bible in terms of a sufficient, adequate, worthy challenge to this energy transition. It really does uncover the lies. It teaches you not only how the world of renewable energy works, but how the industrial civilization works. So so check out the book Bright Green Lies, check out Julia's movie Bright Green Lies at brightgreenlies.com, and also the movie seaoflifemovie.com. Julia, thanks so much for joining us.
Thanks so
Have
much
a great
for having
day.
me.
Okay.